Hi, I'm Eliav from lunar.dev, and in this video I'm going to walk through using Lunar's HAR Log Collector diagnosis plugin. We will work on policies YAML, our configuration file on Lunar Proxy, in order to configure this diagnosis plugin according to our needs step by step. While a deeper drill down is available over on docs.lunar.dev, I will present some of the main features of the HAR Log Collector diagnosis plugin in this video. For the purpose of this presentation, I've brought up two Docker containers on my local machine. One is Lunar Proxy itself, and the other one will stand for a real API provider. It's actually running a local equivalent of httpbin.org, which is actually very useful for testing and local development. For the purpose of collecting HAR logs from two different endpoints, a full policies YAML might look something like this. So there's quite a lot here, as we can see, and basically we're defining two diagnosis plugins per two endpoints. So we have the http/status/path parameter code endpoint, which is a get endpoint, and also http/bin/json, which is another endpoint. But this is actually like a fully fledged YAML, so let's build it step by step. I'm reverting and deleting the whole thing, and we'll start quite easily. Our policies YAML is empty, and we're starting with a very simple global diagnosis plugin. We define the fact that this is an HAR collector by specifying the config as HAR exporter, which exposes two simple configurations for us. One is transaction max size, and the other one is obfuscate. Every diagnosis plugin has an export field, which tells us where do we wish to export the results of the diagnosis process. So let's take it step by step. Transaction max size is useful because HAR logs are essentially JSON records or logs, and these can be quite big. So in order to avoid issues with consuming too much disk space, we allow to set a limit, and this is in bytes. So in this case, we're telling that we wish to have 100,000 bytes as max size per transaction. The obfuscate field allows us to control whether we want to obfuscate the values themselves in the HAR log, such as the body of the response or the header values, etc., or not. We will drill further into this in the next phases of this video. And the export file is actually like fundamental. In order for this diagnosis plugin to work, we do need to specify where do we want the results to get to. So in this case, for simplicity's sake, we're exporting this to file. Another option would be AWS's S3 or Prometheus. In order to actually view the results, I'm choosing file here, and I'm adding an exporter section, which is another top level field in policies YAML. And in this case, I'm telling Lunar Proxy that I want to get the results to a file called output.log, which is located under /var/log/lunar proxy. Great. Once we've done that, we can apply the policies that are currently present in policies YAML. So I'm using the apply_policies command in order to do so. I'm getting a positive confirmation from Lunar Proxy that this is actually working, and the next thing I want to do is make a call using CURL to Lunar Proxy with http-bin as the final destination of this call. So I'm using CURL, and I'm telling Lunar Proxy that the actual host is http-bin. Again, this is running locally on my machine under this name, http-bin, using Docker Compose. And the endpoint under http-bin that we're referring to is /status/200. This is a very, very simple endpoint that is available from http-bin, which returns a simple 200. Had I mentioned another status code here, it would return this very status code that was mentioned. So anything goes. The actual direct address of this call is lunar proxy, which is running under localhost at port 8000. So once I make the call, I can see that I'm getting a 200 back as I expected, and this call indeed passed through lunar proxy, as we can see by the xlunar sequence ID response header that is present here. Fantastic. The next thing we can do is validate that our HAR logs are indeed collected. So for this, we can use the diagnose tool, which actually reads from file. It reads from the very file that we've configured in policies YAML. If we just run it, we can see that there is currently one sample. So we can inspect this very sample and by adding the one as parameter. And I'm piping this via JQ, which is a very nice JSON viewer. Let's clean the screen for cleanliness. And once I do that, I can see that I have the full HAR log for that very first call that we just made. We can see that the URL of the, there is one entry, and the URL of the request is http bin/status/200. And there are the headers, there's the response. The whole idea of HAR is being a format that allows us to describe in a very consistent and standardized way the way that HTTP requests and responses look like. So yeah, this is pretty great. We have the empty response body under response content, as we can see here, and the full headers of the response as well. This was very simple. We started off with a very simple configuration of policies YAML. But what if we want to do something a bit more specific? Because as you can see here, the status code can be 200, can be 400, can be any valid status code. And I do not wish to catch anything else using my HAR collector diagnosis plugin. I only want to get that very endpoint, http bin/status/200 or 400, etc., but only that endpoint. In order to do that, we can avoid using the global definition and use, use the pair endpoint definition. So what I'm doing here is defining a very similar policy, only that this time I'm defining it under endpoints and not under global. And the endpoint is defined as URL and method, where the URL is http bin/status/path parameter code. This allows us to actually catch and match upon any code that will arrive as the second path parameter to the status endpoint. Once we've done that, we can make sure that it actually does what we want. So we can clean the screen, apply our policies using the apply_policies command, and now I'm going to issue two calls to the endpoint using curl. I'm going to use the first one that we've just seen. Okay, I'm getting a 200 back that passed through lunar. Perfect, just what I wanted. And I can issue another one to a 400 endpoint. I'm getting a 400 back, passed through lunar. That's fantastic. And I'm going to make a third one. I'm going to make a third one to another endpoint called /JSON, which actually shouldn't catch anything because we have not defined a policy to match upon it. We dropped the global policy. We only have a policy for the status/status code endpoint. So I'm issuing this code. Great. It did pass through lunar, but it doesn't mean that lunar actually did something with it, because the call was directed to lunar, as we can see here. As of now, I expect to see 3 samples under the diagnose command that I'm using here. So there are 3 samples. The first one that we did before the last 2, and the fourth one is not actually captured because it wasn't matched by our definition in policies YAML, the JSON one. So what we have now is two HAR logs for the status endpoint calls. Let's look at the second one. The second one, as we can see here, is very similar to the first one that we've seen. It's practically the same. And what we're interested in is actually the URL. So I'm using a very specific flavor of JQ here that allows me to drill down into a specific field in the JSON. And I'm interested at how does the URL of the request looks like. And as you can see here, Lunar does obfuscate the URL of the request, because we have turned on the obfuscate flag in policies YAML. You might want to do that in order to keep your data a bit more secure and obfuscated in case you're dealing with sensitive data. And because we have we have a path parameter under code, it might contain sensitive data, and in this case Lunar will obfuscate this. So this actually should probably be 200, but we don't know this right now. If we look at the other one, we could see that it also gets another value as obfuscated value. This one probably stands for 400. And obfuscation covers all things that touch path parameters, query parameters values, and header values, not header keys, header values, and header names, and body values, like whether it's response or request body values, not the like the schema of the response, but or of the payload, but the values themselves. So in this case, we're seeing that the path parameter code is obfuscated, which is the default behavior by Lunar Proxy, by this diagnosis plugin. And the next thing we can do is we want to say, okay, I'm all for obfuscation, but what if I do not want to obfuscate the very status code path parameter? In this case, we can use exclusions, and exclusions allows us to exclude parts of the request and the response from obfuscation in a specific manner, in an opt-in manner. So I'm updating the very same policy for the very same endpoint, and I'm adding under the obfuscate field, I'm adding the exclusions field, which can take the path param field, which accepts an array of strings, or the response headers field, which can take an array of strings as well. So in this case, I'm asking the diagnosis plugin to avoid obfuscating, to obfuscate all the things that needs obfuscation, but to avoid obfuscating the code path param, which we have defined here ourselves, and the response header that is named content length. So once I've done that, I can apply my policies again. Let's clean the screen. I'm cleaning my screen and I'm applying my policies, and then I'm running the very same calls for status 200 and status 400. Perfect. At this stage, I expect to see 5 samples. So let's validate that. There are 5 samples. Perfect. Let's look how number 4 looks like, just to see that it seems familiar to us. It does seem familiar to us, and we can see in the response part, we can see that the content header is actually not obfuscated, while all the rest of the headers are. But let's do that in a more organized manner. So if we inspect the request URL of HAR log number 4, we can see that it is now no longer obfuscating the status code path parameter. The same goes for log number 5. That's a 400, and if we inspect the headers of number 5 as well, this is the way in JQ to access the headers field of the first entry response part, and we can see that everything is obfuscated, only the values. The names are not considered like PII, so they're not obfuscated, but the values are all obfuscated except for the one that we explicitly and deliberately excluded from obfuscation, which is very useful in case we want to like drill down into things and do analyze them. And in case we're interested only in distribution of values, obfuscation is a great thing, but if we really need the data itself, that we might want to consider excluding things. Fantastic. Let's see another endpoint other than status, because status does not have a body in the response. So I'm cleaning my screen and I want to show you how the /JSON endpoint of HTTP bin looks like. Once I make the call, I do get a response body in return that looks like this. It has the top level slideshow field, which has the author field under that, and the slides field as well. And the slides field is actually an array which starts here and ends here. And it includes, every item in the array includes the type field. So that's quite a schema for us to work with. What I want to do now is show us how can we use
exclusion upon obfuscation on body fields. So we're using quite a similar syntax to JQ in order to declare the exclusions in this case. And what I would want to exclude is the slideshow author, in this case yours truly, and all the types for any items under slides. So slides is an array again, and any item, any object under that has a type field, and I want to see the type field. I do not want to obfuscate it. In order to achieve that, I can add another. I'm leaving like the first one intact. We've done with that. That's perfect. And I'm adding another item to my array of endpoints definitions. This one is for HTTP bin/JSON, as you can see. And I'm defining an HR exporter with the same transaction max size that exports to the very same file. It's fine for me at the moment. And I'm under obfuscate, I'm enabling obfuscation, and I'm adding another field to the exclusion field, which is response body paths. And under that one, I'm defining the paths that I wish to exclude from obfuscation. So the first one goes for slideshow.author. We start with dot because it's a field as well. We enter the field and then we navigate to author. And the next one I want to avoid obfuscation is .slideshow.slides, which is an array. And under each item in this array, I want to avoid obfuscation for the type field only. So once we've done that, we can see if it behaves as we want to prove that it's working. I'm applying the policies and I'm making a single call to the JSON endpoint. The same response as we've seen before. It's very consistent, which is great for our purposes. I'm expecting to see 6 samples at the moment, which are indeed present. And what I want to do now is inspect the very response body, which is in HAR format, it's called response.content. So I'm using JQ in order to present the response content. Alas, this is actually a JSON in itself. It's just, it's put in a string. So what we can do is actually a little trick using the from JSON bulletin from JQ that will parse the very JSON that we've received and apply JQ upon it, which is a pretty cool trick and very simple. So this is actually the response body. And as we can see, everything is obfuscated except for slideshow.author, which is yours truly. I mean, date is now obfuscated quite clearly, and title is obfuscated as well. And under slides, there are 2 items, and the type field in each of them is indeed not obfuscated, which is fantastic and exactly what we wanted. All the rest of the fields are entirely obfuscated. And when I'm talking about the field, I'm talking about the field's values, okay? The schema itself, the field names, the keys are never obfuscated because they should not represent PIIs. All right. The next and last thing I want to show you is that in case we revert back to our global definition of the policy, of the HAR collector policy, with or without obfuscation, it is no longer possible for us to control the same things. So once we've done that, we can see that this is actually a bit useless in this context, maybe, or maybe not. But what we can do is we can apply the policy and make a call to the JSON endpoint again. Again, like now we no longer declare that JSON is a known path part, right? We do not know this as part of the URL schema. And I'm making the call. I'm expecting to see 7 samples. I'm seeing 7 samples. Fantastic. And I want to see how the URL looks like. And this is something that is important to remember, that once we've moved a definition to the global scope of policies, we cannot assume that this path part is not a PII. So by default, Lunar proxy and the HAR Log Collector diagnosis plugin will obfuscate it. This is done on purpose in order to avoid leakage of sensitive data. So if you do need to expose the path, whether parts of it or the full path, the right way to go is probably to define it as an endpoint level diagnosis plugin. That's it for today. Thank you.